So I got an email asking me about my thoughts on Tiana's Bayou Adventure, and I was like, what's going on with that? Turns out the thing just doesn't run. So I started looking into it. I'm like, yeah, I think I could make a video about that. It's not my normal video. If you're here for the first time, make sure you like and subscribe, do all that normal stuff, because this one's coming right out of left field.
Now get ready. Here we go.
Ladies and gentlemen, welcome to the Ryan Ride Mechanic channel. How the heck are you doing today? On today's episode, like I said, we're going to be going over Tiana's Bayou Adventure over there at Disney World. Now, this is what Splash Mountain was shut down to become. So we've lost Splash Mountain, or what it used to be, and it's now Tiana's Bayou Adventure. For those who don't know, Splash Mountain was taken down. It was simply just given a theming and animatronic overlay. The ride layout is the same. The vehicles are the same. As far as you could think, I mean, the control system would probably even be the same. Disney likes to use a lot more I/O for animatronics and theming and things like that. So there might have been some controls upgrades to simply handle the new equipment going in. So one of the things that happened as soon as they started operating the ride is that it started breaking down. And that's what I wanted to go over. So to do this, we're going to have to kind of discuss the difference. It's not my normal video that I do, but the difference is going to be here that Disney and a handful of other parks are they're a immersive environment park. So what they care a lot about, Disney and Universal and things like that, is the show they produce, as opposed to your theme parks that are local or your amusement parks that are local. They don't really have a show to the ride. They have some theming elements to the ride, but not much. So you get on the ride and you just go on the ride, and that is it. And it might have some stuff in the queue line. The building might be themed up nice and good, but it's not really part of the show. Disney likes to give you an entire show. And same with Universal too. They love giving you the full show, and it just so happens the ride is part of that show. It's the narration, it's how it gets you through that show. So what happens is that on an amusement ride like you go to at your local park, the thing runs, it works fine, and then the ride eventually throws out a fault, and they're like, okay, we have to stop operation of the ride. Well, Disney and Universal's rides also do that too. They say we go just fine, and then the ride might encounter like, oh, tripped a circuit breaker, and it's like, okay, we have to stop the ride until that problem is resolved. But when it comes to Disney, Universal, and parks like that, there's plenty of parks all over that do this. So don't just think it's limited to these that I'm naming. What happens with these parks is that they have show elements that the ride vehicles go through. They have theming, they have lighting interactions, they have all sorts of things that produce the overall show effect that you are there to see, that you're paying a lot of money to see. So one of the things is that they say, well, if that show element doesn't work, the ride doesn't work. It's like, well, wait, you would take down the ride just because the show element? It's like, yes, they will do that. So I worked with a friend who worked with Universal and things like that, and he said what they did is they had basically a scorecard, and they would go through the ride and they would look at all of the elements, and they knew exactly what was supposed to be there, things that you and I would probably miss, and just like, oh, I didn't even notice that was happening. But they know about it, they see that stuff. All those show elements have to work. And that show element package produces a score. So they're going along and they say, okay, we have in the theming in the background over there, we have a light out. Well, that's -1 point because there's a light out over there. Now, if it's not a main thing, I'm assuming it's like the entire effect doesn't work, that would be a main thing or a very high pointage ride. So what they do afterwards is they add all the points up, and they basically say the ride is allowed to operate. Let's just make it easy and say out of 100 points, the ride is allowed to operate after it hits 94 points. 94 points and above, the ride is allowed to operate. So when they go through there and everyone checks their stuff in the morning time, if the ride points isn't high enough, they say, nope, we're not going to operate this until you get a handful of these things fixed. So that is just a operator maintenance, show productions, package feedback that the park has to have. So we go into a place like Disney, and let's talk about their show packages. Well, if their show doesn't work, then the ride doesn't work. It's quite simple. When stuff breaks down, they shut the ride down for it. So, for example, over there at Disney's Na'vi River Journey at Animal Kingdom, they have the big shaman of the forest at the end. That's a very complex. It's one of the newer animatronics out there. And when it breaks down, they have to shut the ride down, because what they do is they have to go in and they have to fix that animatronic to where it's back up and running again, or they remove the animatronic and take it down below scenes and put up a projection of it back there. That's like an alternate plan so that the ride can still operate while they make repairs to it, because the repairs on these things are not exactly easy. It's not just like take one part off real quick, put it back together. They have to have it live, working, moving around. That way they can troubleshoot and see things like that. And it might not just jump out at you right at the beginning of what's wrong. It might be some little tiny hidden thing inside there that's causing it to go down. So the animatronics play a very big role in keeping these rides running. So it's understandable when the animatronics break down, the ride breaks down. So the majority of animatronics work off of loops, basically. The very early style animatronics, I believe there's something like, in Disney it's something like an A10 animatronic, which is something you would find these days if you go to It's a Small World. You go to Pirates of the Caribbean, things like that. They look kind of like static puppets or static figures that are mounted to something that moves. In It's a Small World, they have little dolls that look like they're dancing. Well, if you look down behind the scenes, you can see what moves them. It's not very hard to do. But it's typically underneath the doll. It's simply just a motor with a wheel and a cam sticking off of it. And as the cam rolls around, it goes up and down, which causes that up movement, causes the doll to move. Arms to raise, legs to move, something along those lines. So that is a static loop. Pirates of the Caribbean, you have the infamous scene where the pirates are chasing the women, or these days the women are chasing the pirates. And they just go around in circles, because what those are is those two figurines mounted to a wooden or a board basically up there that's on a rotisserie, kind of like a Lazy Susan. And the thing just sits there and a wheel spins it, and the two just run around the theming that's there. But all they are is simply static figures with a motor turning them. You turn them on, you turn them off, it doesn't matter. They just sit there and spin the entire time. You viewing these things, when these are these static loops, you viewing these has no consequence whatsoever. When the boat floats by on Pirates of the Caribbean and you look out and you see that lady chasing the pirate there, it does not matter that they're on the back side of it and then they come around, or on the front side of it and then they go back around. That doesn't matter at all to you, because it just sits there continuously and does that. A lot of the pirates in Pirates of the Caribbean, they're sitting there repeating the same thing. They're repeating the same thing over and over again. And that is also a loop. So those loops are built specifically for the timing of whatever is coming by. So when they started to work with these loops and figure this out, they said, we're going to put boats in the water and they're going to float by. Well, the average attention span is like this. And here's my attention span, and I'm looking around. So by the time my attention span gets to that animatronic, and then I start to notice it, and I walk, as I float by, I'm just kind of like, oh yeah, there it is, and then my attention span shifts. That's a time interval. So they build the animatronics to work in that time interval. So if you sit there while a boat's moving slow, maybe you're in a stuck area where the ride has stopped the boats for some reason, you will sit there and they will just continue to do the same thing over and over and over again. You'll notice it's about like a 10 to 15 second loop. Every 10 seconds, it goes by and something happens. And a lot of times these are timed with audio, so it looks like they're saying something or doing something like that. So, but again, that's inconsequential. If you hear them saying, we want the rum, if you hear them saying that 10 seconds ago, And now 10 seconds later, it doesn't really matter to you. It's not part of the story. So that is a closed loop. The animatronics just sit there on a single loop and keep going and going and going. It'd be like me as the boat's going by, and I'm just sitting there going, how's it going? How's it going? How's it going? Every once in a while, you would look up and you would see me sitting there going, how's it going? And that's it. That is the loop. So we take our little vehicle, it goes by during that timeline, and there I am. How's it going? And I just keep doing that over and over and over again. So we moved away from that into now what they use on a lot of the newer stuff, which are triggered loops. And these aren't official terms from Disney or anything like that. These are just what I'm calling them. This is a triggered loop. It is still the exact same thing. It's me sitting there going, how's it going? But I only do that at a certain time because I'm going to be doing either nothing or something else until the boat comes by, and then you'll come by and you'll see me, and then I'll suddenly start going, how's it going? So there is a reason they do this stuff. And typically that reason is because it seems to be more interactive with the guests. So the guests get more of an interaction back from that animatronic. So they stop feeling like they're just writing through something, and now they start feeling like they're participating in something. So it's a mental mindset, right? So as the guests go by, it feels more interactive to them. But that comes at a price. So what happens on these triggered loops is that as you're coming around the corner, you will see, let's just use my Ryan, the Ride Mechanic animatronic, right? And you will come by that corner and you will just see me there. And I ain't doing anything. And as you come up on me, I still ain't doing anything. Now, what's that problem? Most people hit this, especially with animatronics. It's called the uncanny valley. The uncanny valley is something where your brain says it's fake. We know it's fake, but it's also kind of realistic. And it might give you goosebumps. It might give you those goosebumps on your skin, and something in your brain just might start going like, oh, this doesn't seem right. And you start getting this weird feeling. Some people actually get afraid of things like that. So, and then when that boat or when that car, whatever it is, comes close enough, it suddenly goes, how's it going? And then stops again. Now, these things are typically spotlighted through Disney attractions because they use these all over the place, but they're spotlighted. So what happens is that while you're sitting there static, not doing anything, your attention is focused on something else. Something else is happening. And then suddenly, when that thing is triggered, pop up and go, how's it going? And then your attention is shifted to the next thing again. This is also the same exact things that we do inside of a haunted house. You know, when you build a haunted house or when you go to a haunted house, those attractions are triggered. Those animatronics are triggered. So they sit there static until you walk by, and then one will jump out at you or one will start moving. I built a haunted house where I did that myself. It's like you walk through, I built it in my garage, right? I walked through, did something, I triggered the animatronic, and then just ahead of you where you were walking, a person started flopping up and down on this table looking thing. So, and it made a bunch of noise. So it was kind of like a jump scare. Well, when you have nothing else to focus on, and you could just see that animatronic sitting still and not moving, it gets really creepy. So they recognized that, and they said, okay, we can't have that. So let's look at what a triggered loop looks like. I'll put a little thing on screen that comes by and basically triggers the thing. So we'll sit there and go, how's it going? That's it, right? It looks kind of weird. And they realized that looks weird. So what they did is they started doing triggered animatronics, but then it went back to having a a B loop. So the character triggered with a B loop, character is constantly doing something. Don't know what they're doing, but they're constantly doing something. With animatronics, you can have them doing all sorts of things. Most of the things that you see that you'll recognize in rides and everything else is you'll see characters being jolly, bobbing around, dancing, doing something because it makes sense. So now let's do the same exact thing, but let's use that B-roll and do that. So let's try that. I'll just move around, be like, how's it going? Still not the best, but it works. You see the character moving, you see the interaction, they could constantly light them, doing that sort of stuff. So that is basically the loops of static versus triggered with like a B loop running in the thing. So that's how animatronics are on that loop, constantly helping that show along. Now the thing is that at that point, Tiana's Bayou Adventure, the boat takes on the storyline. So the story does not unfold until the boat gets there, which is cool, but that runs into other problems. You have to trigger these effects. How do we trigger effects? Well, we always want to use the ride vehicle to trigger effect. On X2, as the ride vehicle comes back down and it starts shooting fire out above the vehicle, as the vehicle is passing by, it runs by a proximity sensor. And the proximity sensor tells, which typically when you're dealing with external effects, the proximity sensor tells the show effects controller to produce whatever the show effect is. In X2 case, it's fire. So that's really great for roller coasters because roller coasters operate on two rails. The vehicle goes down a predetermined ride path and it knows exactly where it's going. Proximity sensors are great because they can sense things going by them, and in day, night, fog, rain, it doesn't matter, they can go right by those things. So the trigger in those cases is proximity sensor. Some places like to use a little optical fork as the vehicle passes through the optical fork. It will say, okay, I know what I'm doing now, and it triggers. The problem with optical forks is that when you get high humidity, rain, fog, sunlight, when it goes into certain areas, those effects stop working. Those fork sensors will stop working. So you have to use something else. Also in a water ride like Tiana's Bayou Adventure, that you have to use optical because boats do what? They float. They're not even either. If you have a bunch of big people sitting in back and light people sitting in front, the boat's tilted towards the back. It could be tilted towards one side. Depending on the water level, it could be running high, low, to the left of the flume, to the right of the flume, all sorts of things. So you have to pretty much stretch optical across there, which means every time the effects up there need to be triggered differently, you have to either move the optical photo eyes around that set somehow, which Disney does not like doing that because all their photo eyes are nice and concealed and covered so you don't see them. Because if you were to see them, it'd be a ton of little green and red lights all over the place with senders and receivers and everything else. They don't want to do that, so they go, okay, they hide them. So then what do? It's like, well, you put an optical fork there and the boat passes by, and then in programming, in those animatronics, you set a delay. And you say, okay, once it triggers here, we're going to count to 3 because the average speed of the boat moves it along there. And then it's like, we go 1, 2, 3, and then we trigger the effect. Okay, so those are some of the triggers that we would use to start the show scenes for those animatronics. Again, those early animatronics that like Disney uses, Pirates of the Caribbean, things like that, they simply just sit there and go. There is no triggers for them because they're always on. Literally, they go down and they go and have to turn off a knife disconnect on some of the old ones to actually stop them from moving. But it doesn't really matter. Newer stuff, things that are more integrated with the system, the actual control system of the ride, they're able to hit essentially a stop button and actually stop all the animation in the area. Kind of a pain in the butt from what I understand to get that started back up again because things fall out of sync with the audio. Audio being synced up is a massive part of this. If the audio is off by a little bit, your brain doesn't like it. So So what I'm told is, right, ride stops, okay, one thing, all the animatronics still go, and it's not until they have to do like an evacuation or a shutdown at the end of the night is when the animatronics are actually put into a stop mode. Okay, so now I want to talk about some of the animatronics themselves, and this is mainly Disney's animatronics because there's a lot of information out there, and this is a super high level look at animatronics. It is not a deep dive at all. We're going to call this a 40,000 foot overview of the animatronics what Disney uses. So the old animatronics that are used, and we're talking characters that can actually move around and do things. These were things like the early ones, Great Moments in Time with Mr. Lincoln, Carousel Progress, things like that. These were like the A10 animatronics. These were the animatronics way back when before computers were controlling everything, they had hydraulic systems running them. So they had a bunch of hydraulic cylinders all over the exoskeleton, well, I guess it would be the endoskeleton at that point in time. Kind of looks like a Terminator on the inside. That might not be a good analogy, but whatever, we're going to stick with it. So you've got hydraulic cylinders running all over the inside, and you have a pump that produces high pressure to push into those. That way that little tiny cylinder with high pressure on it can move a big thing. So you can put a little tiny cylinder, only 15 millimeters in diameter underneath the arm like that. And then when I put, 800 PSI to it, the arm comes up. Okay, sorry, I did the wrong noise. That noise was for pneumatics. So they use hydraulic cylinders to do everything. And what they would do is they would use this rotisserie looking thing with looked like a whole bunch of record discs inside there. The discs were cut into a lobe, looks like a funny pattern like a star. And then as that lobe went up and down, it would push on the hydraulic actuators and actually let fluid flow through to the hydraulic itself. You push the actuator up, it would fill the cylinder with fluid, and when you brought it back down, it would start releasing the fluid back out of it. So you had all these fingers on there running in and out of sequence, and then that would move everything. That was okay, but those were very hard to sync up because they were kind of sitting there solo, just spinning around. You could start and stop them, but starting them with audio, and depending on how fast the thing spun up, the temperature of the hydraulic fluid, all that other stuff, they're kind of complex to work on. Not to mention, eventually you would have a breakdown. And I remember reading one thing, I think it was in maybe a More Mouse Tales book or something like that, where Great Moments in Time, Mr. Lincoln went to stand up and blew a hydraulic line off on the inside. Now these lines are very tiny, so they don't like gush fluid everywhere, but the hydraulic fluid they were using was red. Automatic transmission fluid works as a great hydraulic fluid, in case you're wondering. So that's what I picture in my mind, was red automatic transmission style fluid being pumped out. And it just so happens that it started getting all over the top of the animatronic, and somebody thought that Mr. Lincoln was shot. I was like, how ironic. But they're prone to some of those failures and breakdowns like that. Those were in use for a long time, and then Disney came out with the next level of animatronic control. These were A100s. The A100s basically still used hydraulic cylinders to do the heavy lifting and all that sort of stuff. But then they started putting in microelectric actuators. So these are electromechanical things. This is something, if you think about it, it's like a cylinder on a pinball machine. You energize a cylinder, the little plunger sucks down inside there, but you mount the cylinder on one side and the plunger to the other side, and then when you energize it, you can actually move something. It's like, okay, so that's that movement, you energize it and you get movement out the other end. That's an electromechanical effect. Electricity runs it, but it produces a mechanical effect on the other side. So electromechanicals were used to do things like move eyelids and get eyes to shift left and right. A100s you could see because there was no middle ground to them. It was simply just a left and a right. It was open, it was closed, there was no in between. During that A100's lifetime, they made multiple progressions inside of there and went away from electromechanicals just being snap on and off to things that had finite control. Now we can use DC servos and things like that. Instead of getting eye movement snap left and snap right, you can now get eye movements where you calmly can look to the right and then snap back to the left. and do things like that. So you can have more finite control over that. But there's only so far that technology can go. You still had hydraulics doing the heavy lifting in the background. Maybe they did move in some pneumatic things depending on the situation and where it was. But control was always a big issue with those because it took a lot to run them. Integrated those two together and basically started the show, you would start to get more fluid-like movements out of those animatronics. There would be more things where they could now lift the arm up and articulate the wrist and maybe open the hand and do something like that, but they were still kind of boxy, still kind of heavy duty to move, because you still had hydraulics controlling with tiny electrical actuators inside of there doing other things, and we didn't care about feedback on that stuff at all, because you can just tell whatever it was, the DC little servo, just go to this position and it will run to that position. Just say go back. Say, okay, go back. But then mechanically it was all interset to where it would just come back down and start over again. Well, okay, what's the next step of evolution from there? Enter the A1000s. These are the most complicated animatronics that Disney has ever built. And they also break down the most. Why? Because technology does that to you. Technology isn't also necessarily user-friendly for people. So what are these? These are fully electronic things. There are no more hydraulics back in there, but they're fully electric. Everything is run off of DC motors, stepper servos, and things like that, and technology that I don't even know exists right now. So they use all these fancy electronics to make everything look very fluid and very lifelike now. And they give the face lots of expressions, and they can get a shocked face or a confused look on them or anything else. And they're becoming more lifelike than they've ever been before. That's really great. What's going on with Tiana's Bayou Adventure? Well, these animatronics have to start from somewhere. They start from a position that when they're programmed, they probably programmed in something like a 0 position or a start position. That everything in that animatronic has to go back to that position to ensure that it can restart its loop again. Now, these things are done on those continual loops as well too, because let's say the character is dancing. If you've ever noticed this before in some of the attractions, you might notice it after you see this video. But the character might be dancing, moving along, and then right before they start talking, you might see them do this little dip and then start talking again, or interact with the people again. So what's happening is that they're doing that fluid dance, and then they do this little dip, and then they start going, and they start talking with you. That's because that is the interruption, that is the stop of that B loop that I was talking about, and that is the start of the triggered show. So what has to happen is they're dancing, they're doing their little thing, and then you come along and it says trigger. And it goes, okay, so it has to stop the B loop. And the animatronic has to stop dancing. And then it says, okay, from wherever you are, go back to your home position. The animatronic goes back to its home position. And then as soon as all of its internals report and say, I'm at my home position, everything's safe, then it says, okay, start the show. And then it starts the show. And then it starts talking to you. It starts interacting. It starts doing its bit, whatever it may be, going back and forth. Now, in Tiana's Bayou Adventure, a lot of these things sit static. And I have a theory as to why that is, but we'll talk about that a little bit later on. So you get this thing that doesn't have to be in a B loop. It's simply just sitting there. And then you come along and start, and it just says, okay, everything's good, and I go. Now, it breaks down now. It breaks down a lot. And they're saying, why is it breaking down a lot? My theory, again, I've got no behind-the-scenes information. No one's talking to me behind the scenes. Disney knows better than that. So what happens is that those characters go back to that start position. Remember I said we killed the B loop, and then it has to go back to its start position or its ready position, 0 position, whatever you want to call it. Has to go back to that position and wait there until all of its internals say, I'm okay. For bigger rides, we know this for industrial machinery. What's this process called? This is called homing. When you come in at the end of the ride and your vehicle comes in and it slows down and slows, and then comes to a stop, and more complex vehicles like flyers and things like that, There's a lot of sensors on the track making sure that vehicle is in the exact right place. And before it unlocks the restraints, it's making sure that motors are turned off, things are in the correct position, gates are closed, flooring is in the right place, the ride is in the correct condition, all those things before it allows those restraints to become unlocked. Well, this is the same thing an animatronic does too. Before it starts its loop, it says, go back to 0, and it says, okay, I'm back in 0, and it's waiting for all of those sensors, all of those feedback position sensors inside the animatronic to go back to their 0 state, or wherever they were told. If it said my arm had to be at, we'll just throw a thing. Well, if the arm had to be at 15 degrees, it's waiting for that arm to return to 15 degrees. Okay, so everything has to be dead on balls accurate in order to start that animatronic back up, because if it's not, you could have motors running into other servos and things like that, and it might break the animatronic on the inside. So those things are extremely expensive. I don't remember the price tag off the top of my head, but I was just like, whoo, man, there's a lot of money wrapped up in those things. So they don't want to damage them. So they want to preserve them as long as they can. So we never want to start an animatronic that's out of position. If those animatronic components inside, whatever they may be, remember there's hundreds of them inside these new animatronics, if they're off by even the slightest little bit, it produces a fault. It produces a warning. It won't let the animatronic start. And I'm not sure of their fault structures or how they do it, but it might be one little thing and it simply just tells the whole ride that, hey, this thing isn't working. And then I'm sure at some point in time it cascades enough information out to where the ride may actually shut down, to where it said something's not working right. That part, I'm not too sure. It's all about how the show package is integrated with the ride package, and that is a very complex handover. The ride package is going to run whether it's safe or not, but the show package is basically producing a yes-no. At this point in the video, if you haven't already, please make sure you like and subscribe and give me some comments down there. Let me know if you got any fun stories to add on to these. And then let me know if you want to see something for topics in the future too. I'm always up for new stuff. I've got a list of things that I'm making, but sometimes somebody says something and I'm like, oh yeah, let's do that one real quick. That really sounds like fun. I do enjoy getting that information. You guys come up with a lot of good ideas for videos, so let me know if you got them. You can also email me at ryantherideMechanic@yahoo.com. Let's get back into the video. Since the inside of the animatronics are filled with that highly sensitive electronic equipment, that means we have to do a lot of power conditioning. Power conditioning is something that inside of a ride, inside of a building, you have power running all over the place, just like in your house right now, in your apartment. You have power running all throughout the walls, underneath you, on top of you. Power's running everywhere. Well, when it comes to controlling motors, servos, finite position sensors, and things like that, you have a difference. There's clean power and dirty power. Dirty power has lots of spikes and waves in it. So they take, the power coming out of your wall. We're in the US here, so, you have 110, 115 volts coming out of there. See how there's a range right there? Yeah, I could put a voltmeter on it. It could be 110, it could be 115, it could be 120, it could be 125. There's a window. The power goes up and down. It actually depends on all my neighbors and everybody else around me and the demand on the grid. Depending on how the rest of the system functions in my house and everything else, you'll notice this one. How about that? You're sitting there and someone turns on a vacuum cleaner, or you turn on a vacuum cleaner. You ever notice your lights dim and come back up? That is a signal of dirty power. You are creating a draw on that power, and power suddenly just goes down and comes back up while you've increased demand on it. So for control systems, ride control systems, animatronic control systems, anything else like that, they spend a lot of money on power conditioning systems. These are systems, they're basically uninterruptible power supplies. They bring the power in, they break it down into a very large DC bank and store it as DC power, and then they reassemble it and make this very clean, consistent, extremely smooth power coming out of there that doesn't waver up and down or anything else. And that whole power conditioning system is designed to put out that exact power at all times. So the more expensive it is, the more narrow the window gets on the power that it can provide. So there's also things like you have residual ground currents circulating through buildings and things like that, grounds that aren't quite as good as the one next to it. Well, when that ground is bad, stuff, current, and electricity just travels to the other side. So if that one's bad too, it travels further down the line. Well, if you keep doing that, you actually start getting ground current that's going through there. And the ground current can feed back into the neutral or whatever else in the system and create all sorts of stuff. There's electrical engineers that can talk your ear off about all this. I know like this much about this stuff. It's not much at all because it's a huge complex topic. An electrical engineer can sit here probably and spend hours talking about just ground voltage. I mean, it's such a massive topic, it's unbelievable. But you have to do power conditioning. So power going to these animatronics is a really, really big key to them. I've known myself, if you start dipping power in certain areas of the ride, you'll start getting things like ghost trains. You'll start getting faults on sensors, even though they're working just fine. You'll have all sorts of trouble with the ride. So you want to make sure your power is right in that narrow window exactly where it has to be. So let's move on to water. They pull the water from an external source on that ride, like a lot of water rides do. They simply fill it up from that external source and run it around on the inside of there. That water is very hot. That means the water has a lot of energy wrapped up in it. So when you cool a building down and try to produce a cold environment, and then you run hot water through the middle of it, you get lots of condensation. Now, the easiest thing to do to prevent this is actually to warm the building. If you make the building hotter and hotter and you run that warm water through there, eventually it stops condensating and just becomes normal. Guess what? Your animatronics don't like warm and hot temperatures. They also don't like condensation. They don't like water. That's not a new thing. I remember watching specials when they made the Jaws movie. They had the shark in the water, and it was designed to be in the water. They built it to be watertight and everything else, but it would get in there and the thing would shake extremely violently because all of the mechanics on the inside and the electrics on the inside were getting damp, and they started fighting each other. So they had all sorts of troubles with that. Well, kind of sounds like what's happening out there right now. Like those things are getting damp, and they might be fighting with each other. The internal components of the A1000s are starting to fight with each other. How could that be? It's like, well, if you think about it, warm, humid day, you go out there, what do you start doing? You start sweating, right? You get really sweaty, your clothes get wet. Well, it's the same thing in a water ride. You have water around you constantly, and humidity and condensation, everything starts to get wet. Even the clothing that those animatronics are wearing is starting to get wet. Well, what happens when you have these little finite motors moving in these little tiny little windows? What happens when that stuff starts to get wet? Well, it gets heavier. Well, who cares? Well, if I took a servo and I said I need you to lift this arm up, and then when I'm programming that servo setup, I said I need one on the back side of the arm and I need one on the front side of the arm, maybe 2 and 1 or 2 and 2. And then I'm going to use a program and I'm going to say I want to lift this arm up. How do I do that? Well, I put X amount of current through it. I give it a certain number of steps. I give it all these different parameters to do that with. Well, that's great when you're programming it inside of a studio where the environment never changes. When the environment changes and we add weight to it suddenly, what happens? Well, you need more. You need more power. You need more current. You need more torque. You need more of everything. Well, what happens when you have 30 servos controlling one arm and you suddenly start saying, I need more? Well, some servos aren't going to like that. They're going to start saying, well, I already gave you more. You can't have it. So then you get a heavy pull on one side, and where it's supposed to be a gentle push on the other side, it suddenly gets jerked and it says no, and it actually pulls its arm back to counteract it. It's a resistive thing. So that's when you get no, it's going to pull, and then not much of a push on the other side, and it's like, wait, and it goes, nope, and it starts fighting with itself, and it starts doing this, it starts shaking. So you hear that all the time in animatronics. They say they'll start shaking, and the shaking is all the sensors and the servos fighting with each other internally, saying where this is supposed to be here and it's not supposed to be there. So it keeps bouncing back and forth, and what that is inside of a program. That's that drive program that's working and trying to control everything. It says, here's my maximum value, here's my minimum value. As long as we're in between the two, it's fine. And then that works great. That little needle stays right in between those two parameters. No problem. I got this all day long. And then you start doing things like running the joints out of oil. You start making the clothing heavy. You start adding moisture to the environment, which washes oil out of the joints and things like that. And then those movements become not so smooth anymore. And now it might start running into a hiccup. Where might that hiccup be? It might say, here's my max current on this side, minimum on this side. It says, move the arm, and that needle comes up, and it goes fine, 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 and suddenly goes, whoop, and it goes right to that max current, and then suddenly it breaks past that point, and then goes back down. Well, everything doing that all of a sudden causes that shaking effect, because it's not just that one thing. It's not like arm, here's your current. No. It's hundreds of things that all have to work together. We've actually seen this in drives on working on roller coasters and things like that, where the drive will go up to its current, it will hit it, and then it will back down, but then its speed becomes the minimum. So it goes high current, low speed, high current, low speed, high current, low speed, and it just sits there and does that back and forth until you get in there, work with the drive, and you have to smooth out those parameters until the thing works properly and works smooth like it's supposed to. Well, that sounds well and good, but can you imagine on these A1000s where there's thousands of things that have to happen all at the same time? You can't just go back there and like, oh, yep, there we go, it's fixed. Nope, that's not the case. It takes people programming it constantly. So water coming into the building, not necessarily a great thing. Lots of humidity. Humidity causes lubrication to run out and all sorts of other things, clothing to get wet, and then all those animatronics are going to start fighting with each other. What happens there? That prevents a lot of them from probably going back to that start position. It's like, okay, what happens if we don't make the start position? Let's talk about the ride. All right, so on the ride, you have these boats coming through. You have now moved from loop animatronics that are just constantly talking and singing to this loop soundtrack, and they're just constantly doing this thing. Zippity-doo-dah, what is that, like a minute 15 track or something like that? All right, so they were constantly doing that on this minute 15 loop, over and over and over and over and over again, constantly. And now you said, nope, we don't want to do that. We want to produce this show effect. So now we're going to triggered. It's like, great, triggered. All right, here we go. What do we have to do? Well, we only want one boat to see the show. Okay, how are we going to do that? Well, we have to slow the boats down. That way one boat sees it. Okay, so we're going to have to decrease the amount of water running through the ride. All right, how do we do that? Well, you got to turn pumps off. Plain and simple, you turn pumps off on water rides and the water ride slows down or comes to a stop. I've noticed that a lot watching people's videos and things like that. There's always a lot of boats backed up. Why is there always boats backed up in areas where there was nothing before? Because the areas where I've been noticing these boats backed up is always in front of one of these show effects. It's in front of one of these big A1000 animatronics running up there. So that's what they're doing. They're slowing the boats down so that when it comes there, it goes, all right, and it says, and the animatronic says, I'm ready to start the show. And then the ride goes, okay, show's ready, start it. And then they go up there. One thing I'm looking at is one of the characters on the, let's see, that would be the second lift going up, which is right on the other side of the drop. There seems to be a big backup of boats right there. So I have a feeling one of the reasons that the ride shuts down all the time is because they said we need to slow the boats down. Because they slowed the boats down, you now have this system that wasn't tuned, by that I mean the ride control system, it wasn't tuned to run this slower speed. There's all sorts of hydrodynamic elements in water rides that you could do to affect them. I mean, there's thousands of different ways to do a single thing. So what happened was they slowed the boats down, and they said, okay, and they were hoping that they slowed the boat down enough to where when it comes around and gets to, let's say, that B lift, or lift number 2, whatever they want to call the thing, that the animatronic, that A1000, was sitting there and saying, I'm ready to go, let's go. And it does, pretty much every time. But every once in a while, it slows down. And when it slows down just a little bit, then that next boat coming up says, I'm ready to go, and the ride control system says, wait, pause. Are you ready to perform over there? Yes, I'm ready to perform now. It's like, oh, start the lift up. Bring that boat up. Great. Once you do that, and people know where I'm going with this a lot of times at work, have worked rides with multiple block systems, like a big Wild Mouse type ride that's got like 7, 8 vehicles on the track. Once you start backing that first vehicle up, it starts a cascading failure that makes a worm goes backwards all the way through the ride. And vehicles just start stacking up, or in this case it's boats. They start stacking up one right after the other until eventually you hit what in layman's terms would be gridlock traffic. Until eventually you gridlock the ride and you can't dispatch because all the block zones ahead of it are occupied. Now, that is the ride shutting down. The ride saying, okay, I have to shut down because now my block systems are too occupied. We've gone into what's I've been told many times and been experienced with is what's called a cascading block failure, which is there where each vehicle comes up to just a block and it stops it. Stopped, 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 stopped. And it happens all the way throughout the entire ride. Now, that's the ride control system. Now, also what I have a feeling with, part of this, is that they're coming up there and they're going to these big A1000 show scenes, and the show scene has not reset. It's not done. It's not ready for one reason or another. Now, it could be it's still waiting for the boat in front of it to go. So it could just be like, hey, that boat's not exited yet. We're still waiting. Or it could be one of my big A1000 animatronics is not back in its 0 position. When you look at it from the outside, it's in its 0 position. It's ready to go. But internally, it might have something that's off by just 0.5 millimeter. And it says, nope, I'm not ready to go yet. They've obviously programmed a window into that. I could hear the comments now. Well, you think they would have programmed a window into that? Yeah, they did. They said, okay, this thing has to come back to 0. We'll use degrees. The arm has to come back to 0 degrees. But we're okay. In fact, if we move it back to -3 degrees, we're okay. And if we go on the other side to negative or to +5 degrees, we're okay. So it sits in that window, -3 to 5 degrees. The arm could be somewhere in there, and the animatronic is considered zeroed, ready to start, ready to go. Cool. What happened is that when this particular animatronic returned to 0, it went to, remember, -3 and 5, it went to 6. And it is just sitting there at 6 degrees out instead of 5 degrees out. And it's just that 1 degree difference. And this is where temperature comes back in. Why is it sitting at 1 degree difference? Well, it could have been the frame got too hot. Could have been there's too much moisture and there wasn't enough lubricant for that arm to return back down to under that 5 degree mark. All sorts of these factors start to come into play. Hey, remember we were talking about power earlier? Hey, maybe there's dirty power running through there. Maybe the ride was already running at its maximum power, pulling things off the circuit, and they're like, we need more power. Okay, because those animatronics now use much more power. How do we get more power to the ride? Well, what could we do? We could turn off pumps. I think I already went over turning off pumps. But maybe it's not to slow the boats down. Maybe they turned off pumps because they didn't have enough power to run the other A1000s all at the same time. That's a good possibility. What would we have to do to get more power? Assuming there was more power in the loop outside of the ride, you would have to put in a bigger transformer. Really big transformer out there to give the ride more service power. What happens if that ride's already locked in with service power? What that means is that the whole thing outside where that transformer is, that's sitting on a high voltage loop. Let's say it's sitting at 12,000 volts, 12 kV coming to that transformer. Well, if that 12 kV line is already tapped out, meaning it can't handle more load, then that might be a problem. They could say we could put a bigger transformer on there, but if we put a bigger transformer there and run that ride off of that, we won't have enough power for Tron to launch. And it's like, well, that doesn't seem like a good thing. Nope, especially because water rides are very constant. They just constantly pull current and more power and more power and more power to run all those pumps and water and everything. They are not up and down. I've been to places where the park didn't have enough power to run multiple rides at the same time, and they literally have to wait to dispatch rides. Operators would look over and see they'd wait for this, like a launch ride. It launched. And then they would wait for it to finish launching, and then they would go over and dispatch their ride. Some were on communication. I've seen parks interlock. I've heard parks interlock rides between each other. They literally had bulbs on the panel to say when another ride was going through a certain area, so they knew not to send that one because there was not enough power in the park. It could be a power issue. It could be dirty power, which is also causing these animatronics to shut down. Maybe there's have a dirty power problem in that building and the animatronics just can't handle it. I've heard one of the previous engineers talk about, previous Imagineers, don't want to get that wrong, too much respect for those people. I've heard previous Imagineers talk about, like, hey, those things can't run in that temperature. I don't know what those guys were thinking. They're basically, the temperature is too hot for those things. It's like, I can understand that. At the same time, I can't believe anybody would have not thought about that at all during the entire design. Hey, we're going to make an animatronic that costs $1 million. Did anyone ask if it could run outside? No one asked that question. Seriously? Like, I don't think that's it. But maybe this could be one of the things also that is fighting that. Maybe they said, look, it can't run outside this 2 degrees. He said 2 degrees. I think he means probably Celsius, which seems like a bigger window to me. That's, that's roughly like 28 degrees Fahrenheit, if I remember that right. I probably don't, but whatever. Maybe that is one of those things that said, no, it can't operate in those temperatures, but what are we going to do? We are going to add cooling to the building. And maybe they put in some big coolers inside there and tried to cool it down. Remember what happens when you bring hot water into a cool building, it makes things way worse, and it's always been. Not sure if that's the case, but I honestly think they have just animatronics getting wet, causing sluggish behavior, which causes them not to return to their zero state and not to do anything else, and then suddenly the ride doesn't have a ready show signal to start, and now it's stopped the boats and the ride has been shut down. Other things like power going out, fire alarms going off, and weird things like that, that more points at a power distribution problem, like they have a power problem. And another thing is when they don't run the waterfall. At the end of the ride, the very big drop, it's supposed to be what looks like a waterfall. That really has no purpose whatsoever. It could run off. The actual boats don't care. It is simply just going down that. Most rides, they do that waterfall simply for a visual effect. It really doesn't do anything. If they were trying to slow the boats down, however, that minute amount of water running down that drop, coming down there, actually does contribute to some of the flow down that exit flume. So that would be necessary to cut that drop off to prevent some of that flow of water going around, which would push the boats around too fast. But then once you slow boats down there, you're talking about from the top of the drop to the bottom, that's a block segment. And if you don't clear that segment fast enough, the next boat coming up stops. And then the one below it stops. And then the one behind that stops. And then what happens? The show is ready to go, but the block system's not. It says, nope, there's another boat ahead. I can't let that other boat go forward. So the show system sits there and it has to wait. Now, a lot of these animatronics are running with no B loop. There's no backup. That happy dancing I was talking about where the animatronic's not doing anything, it's just kind of sitting there doing nothing but dancing along with that. There could be 2 reasons for that. One, it could be a cost savings measure. Those things are expensive to run. It takes a lot of people to run them. They require a lot of maintenance, oiling, attention to detail, that sort of stuff. So by not having that B-roll play where they're just kind of sitting there dancing in between the stuff, By not having that, you could say that animatronic will cost less money because we don't have to go out there as often to grease it, oil it, service it, make repairs to the small actuators, all that sort of stuff. So you get that uncanny valley where the animatronic is just paused in that start position, waiting for the next boat, and you typically can see it right there, and it looks creepy, waiting for you. So that's one thing. It could have been produced as a cost savings idea. Look, we can save money if we simply just don't run the B-roll on the animatronics. What else could it be? We were just talking about dirty power and power issues. What does killing that B-roll do to us? It saves power. We don't have to run as much power because those animatronics are using less power to run those things. I would be very curious. I have no idea because I don't know the technology being used. It's like way above there, off camera, above my head. But I personally would love to know how much power one of those animatronics used. Because you think about it, it's all small stuff. Some of them are quite big. They are quite heavy. They're big structures on the inside. They use lots of plastic materials and carbon fiber, titanium, and things like that, trying to keep it all lightweight, which keeps your power consumption down. But at the end of the day, they're probably using all DC servo or DC stepper type motors in there, which produce a lot of torque, but they need a lot of power to run at the same time. So I would be very curious to know how much current one of those A1000s actually pulls from what. I imagine they'd probably be fed 220 or 480, some industrial voltage out to them, and then they'd step that power way down and produce, I'm imagining a busing system for the animatronics. A big container in the back that produces a lower voltage, very high current, and you can just bus all the animatronics together. Whether that's the case, I honestly don't know. Speculation, that's what this video is, right? This is all just speculation. Don't know what's going on out there, but I'm looking at it. I was asked to do a video on it, and I thought, hey, this seems like something that I can kind of connect the dots in between looking at it and say, hey, look, I can see the humidity and water. I can see that, but the reason why it's a problem is because it's dragging the animatronics down, and they can't get back to their start position, and then possibly have all of them working together. They could possibly have the boats move too fast, and there's dirty power, and there's wet animatronics. It could be a trifecta running through that thing. Either way, the big question now turns to Disneyland, which is getting the exact same makeover. I would imagine the exact same animatronics. The only positive thing is they don't have the Florida humidity to deal with. Now, the downside is California is a power-hungry area. So the question is if it's dirty power or a lack of power, does Splash Mountain in California have enough power to become Tianas Bayou Adventure? Anyways, I think that's going to do it for this video. If you liked it, let me know. Let me know what your thoughts are. I have a feeling because of this one, I'm going to get a lot more Disney people than I normally get commenting on this video, which I'm honestly kind of cringing about. I mean, I watch a lot of Disney videos myself, and people are kind of ruthless when it comes to Disney stuff. They are not that friendly. So make sure if you're here for the first time, do all the stuff downstairs, like, subscribe, comment, let me know what you think. If you need to reach me, you can always comment. I try to respond to most people. You can also reach me via email at ryantheridermechanic@yahoo.com. And, oh yeah, stay off the air gates. Bye.